So today we are going to understand a Leetcode question, and we are text front we are watching YouTube. Okay, so let's go to understand the today question. Today question we have is 208, and we have to implement try in this one. Okay, so let's understand try. We will do the, you can say, prefix. We'll use tree. You can. Okay, so try pronounced as try. Okay, so the prefix tree is a data structure okay, and used to efficiently store and retrieve keys in the data set of a string. Okay, and there are various application of this data structure such as autocomplete, spell checker, right, that we will see in some second. Okay, so let's implement this try. Okay, try class, and how we'll do that. So there are some functionalities given. Try given as a object to initialize, this one as a, you can say, default constructor. Method is insert, search, start with. These are the methods we have given. Okay, other things we are saying that we have given example this in which we have some input and some output. Okay, so if we'll talk about the input, right, we have given try, then we have given insert, then we have given search, then again we have search, then start with, insert, and search. So what does it mean? Means first of all we are going to insert apple, then we are searching apple and app, and then if we'll do the start with means app, then we'll search insert app and then search app. This is the way, right? So what output should come? So when we are going to do what apple insert, it will return null, right? When we are going to search apple, it should return what? The first time it is we are doing what try, so it will be giving null, right? Second time we are inserting, it will also give null. Third time it will give what search, so it will say true because we have already inserted this one here, so it will give you true. We'll do app, it will give false because this is apple, it will say false. If you try to search start with, it will return you can say, and we are searching what app, start with app, so yeah, we have a start with app. If we are going to search insert, it will app, it will return null because we can insert it, and if you find app, it will return true. So why it is giving here false is because, see, if you are going to search app, right, means app is not there, right, but start with is there, right, apple is there. So in apple what we have APPLE, right? So if you talk about the app, right, so this is there, but if you're going to search this one, so and will not work here, right? So and is something with LE, right, in the last E. So you can start the app, right? You start with search, you can do, and we can find this one app, but if you're searching the app exact, it will not give you, right? Let's understand why it is saying that. So this question has been asked in Google and all the topmost companies, so I can say this is a very important question, right? And if the question is related to hash table, string design, and the tree, right? So try is very important for this topic. Okay, and similar questions we have here, and if you want these links, please ping me in the comment box. So application for this try is autocomplete. Like you are doing a search on the Google, right? You're typing something, it will giving returns something here, right? And once you are choosing this one, it will go to your respective pages. Spell checker, now if you are putting some value here and you are checking the spelling, right? If you are using IP routing, so at the time of IP routing there are some tables A, table B, right? And you can route from router 1 to router 2, right? Next we have chain prediction text, where you can use predicting the text, right? Hello world. And if you are solving the word game like Google we have, right, you can select the words from here and you can make the word. So these are the applications that we are seeing, right? Now understand that try node data structure, right? So try is a rooted tree. Its node have the following fields, you can say. So maximum are links to its children, where each link correspond to one of R character values from the data set alphabet. So what we will see, what we are seeing that in this article we will assume a total R is 26 letters, right? So the number of lowercase Latin letters we have, and boolean fields which are specify whether the note correspond to the end of the key or not, right? So what does it mean? Let's understand here. So it is saying that if we have some element, we have some you can say value, right? So let's suppose I'm considering export, right? So we have E, then okay. So what I'll do from A, B, C, right? I'll take A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, like this we have, right? So first it is copying in from the export. Let's suppose we have this export. So we have E, right? So we will find here if this is that there. So what we will say, there is some method, so in which we will check what is end. So if there is end, so it is what export. Let's suppose we are searching what export, my first name, right? Export fund, right? So what we'll do is from E, if we'll check is this end, so it will say false. No, this is not end. Similarly we'll check what next letter X, right? So X is where? Here, X, Y, G, right? So X will check here. So is this end? No, it is not end. Then we'll check what P. Let's suppose somewhere it is P. Is this end? No, this is not end. Then we'll check what again E. Is this end? It will say no. Next we'll check R. Is this R? Let's suppose R is here, right? So we'll say no. This is not end. Then we'll come T. Let's suppose T is somewhere here, right? So what we'll do? Say it when we come to T, right here, we'll say yeah, this is end, and we'll return is end as a you can say true. Okay, and then it's what it's happened. Your words is completed. Your search is completed. That's why when we are let me clean this one, what I'm talking about. So now what happened previously, we are searching what yeah, we can see here, right? So what we are doing there, the first time what will happen, we have inserted what apple. See, we have inserted what apple. So what will happen, your apple is already there, right here. So if you are searching this one here, right? So our element is what apple, right? We have already inserted here. Okay, so next time what happened, now if we have try contains this data, let's suppose try contains this data. Okay, so when we are going to search what apple, it will say true, right? We have why? Because first we'll check is this and no, is this and no, is this and no, is this not, no, is this and yes, say yes. So exact element we have into the word have into the try. When we are going to search app, right? What happened? We are searching APPE, APP, right? So we'll check this is and is there in 3 places, right? Is and is no. But when we come to the LE, right? So this is no, but this is yes, right? And so that's why it is returning. I think you understood, right? So what we will do? So for any element, right? Let's suppose for any element, let's suppose we are talking about the apple, right? So what we will do from A to Z, right? From A to Z, we will check from the loop. First we'll check the element A. Is there is and element? So it will say no. Is P is int element? It will say no. It is P is element? No. So from here it will say no, is not and it will say yes. So this time it will return true. Okay, like this we will implement the insertion, right? So to insert that, what we will do, we can implement some topics, right? And then we'll what we'll do, we'll implement this one. Okay, so so let's understand how to you can say find the value, right? Into you can say how we will check key in we can implement it. Okay, So let's suppose we have a class we have, right, and we are going to implement try node, suppose. Okay, so what we will do, we will we can implement here, like first of all we'll take a try node, right, and we can say we can say what, we can say we have some links, right, and some values we have, right. So let's suppose link is nothing but our private, and we'll take tree node like this. Again, what will take, we'll take some private, and it's a final int and r, and this is nothing but what, 26 liters, right. So while creating try node, right, we will take links and r, and we can check, we'll also check what if suppose, let me go to here, let me write private, and this is our boolean type, and we can say is and it will return true or false, right. And if we'll talk about the constructor, we can say right try node, and this will return what, this will initialize links, and links will come from what, new try node of you can say r, like this. Okay, I think you understood. Next, what we will do here, once constructor initializes this one, so we'll check, we'll create one public boolean function, and this boolean function will take say contains key, and will take character care of character. Okay, so if this character contains, right, where into the links, right, so we will say return, there is some links is some word value, right. So we'll check onto the links that we have character, right, character, and in the from the character we'll do what, a minus, and then if it is not null, then we will say true, return false, true or false, right. So again, if we have this element, so we say try node, and there is, we can write a get method in which we will pass character c, you can say write character. If this character is already there, right, so what we will do, which return directly, let me write here, so what we will do, we will try to return this like this. Okay, return this one. Okay, if this is there, so we will return the try. Okay, and if we want to add some value there, so we'll say public void, no need to do anything, void put method, and this put method will do what care, and this character, this character will take what, another will take try node, is your node, and when we are going to implement, we'll say we will put into links, and these links will what happen, we have character, and we are doing what, minus a, and we are storing some value, right, where at the node. Now one thing we'll check, that is public, and we can say void set and. Okay, so if this method we are going to call means sorry, then we have to return what, true onto what, the links, right, we are setting, right, we are once we are setting, so we will say on the links is and is method, right, and we'll store here is, and we have already taken our line number 4. Now what we will do, we'll find return public boolean is and function and will return is and that's all. Okay. So what I have taken, first we have taken try node, then we have taken what, int r, and the boolean is and, then we have initializes through the, you can say, constructor, the try, and then we'll check if the character contains, will return, if not then return false, right? Otherwise if you want to add and get character from the try, will links and we'll get a character minus a. If we are talking about to put, we'll say links at that character equal to the node, we'll update a node, and then we'll say if you want to set and, if you want to get end. I think that's you understood, right? Now if we will talk about the insertion, right? So you can say the top two most operations in the tree are insertion for key and search for key, right? So to insert this, right, let's understand what I'm talking about. Okay, this one. So to insert any element, okay, what we will do, sorry, if anybody want to insert something, let's suppose we have some element, right? So first of all, if we are talking about Leetcode, right, let's suppose there is a root node, right? Root node. Okay, so root node will contain we have word lead code, suppose. Okay, so what happen if we are going to insert first two element? Okay, so what will happen, the first node will come and second node will come. Here what will come, L will come, L. Okay, L will come, and the second time what we're going to see, node 3, this is node 3, it will add what, LE, right? So it will go to E, and this is the end of the key. Okay, but if you want to add lead, right, so we'll go again, we'll add one more node, that is node 4, I will say E, we'll find one more element, that is T here, so one more node will add and we'll say T. So end of the key is done here. Okay, but if we will talk about code, one more code we have, so what we will do, we will add one here as a, you can say, new node 6, and we'll see this is C, then we have what, 7 is O, then we have 8, that is our D, and another node what we have 9, that is for E. So this like this we will inserting, this is a new node, we are going to a new code, right? This is our lead, right? This is our lead and this is our code. So code we are inserting into this try. Okay, and that's why we are getting like this. Okay, now so what we will do, we'll implement this one, the insertion, right? Insertion of the key into try, and to do that what we will do, we have already implemented try, this one try, right? Try node we have already implemented here. So what we will do, we are coming to here. Okay, so what we will do here, first of all we'll say let's take that one pivot try node, and we'll say this is our root. So initially we have to take root and then we'll add other nodes, right? And once this is done, we are coming to our try, and we'll say we'll update our root, you can say, and root will become what, new try node. So it's initialized now. Now we'll talk about the insertion of keys into a try. So what we will do, we'll insert word into the try, right? So let's suppose we have this word, and this word will take what, we have our try node, right? So if we'll talk about try node, and this is nothing but node, and this is what coming from root. Okay, so we are taking from root, and then what we will do, we'll make a loop, for loop, and we'll check what, we'll take int I equal to, we'll start from what, 0, then we will go to the word, we have word, and then its last length, till that what we will check if we are not at the last length, right? So what we will do, each time we will say and is not, and is false, right? Otherwise we'll continue adding this one. So what we'll do, we'll take character, and this is our current char, and this current character is nothing but our word dot caret I. So we are updating our current character, and we'll check if this current character, right, if we can check on node, if node dot contains key as the current key as a what current node, right, current character, if that is on the node, right, then we will not do anything. If not, then we will go to add on to the node again. Okay, so we will add, if this is not onto the node, we will add onto the node, and we'll use what our current character, and then you can say new try node. If this is not onto the node, then we will add. If have, then we will not do anything, we will continue that. We'll say node equal to node, and dot will get from our current char, right, like this. After this, once this is done, then what we will do, we'll set if the for is completed, means our node is AND, so we'll set, and we already have AND method, so we will set that we are done, right. Once this is done, we are done with the insertion. Okay, so for the insertion, if we'll talk about the complexity, right, so we are going with all the you can say complexity. So you can say TC for this one, it will become what time complexity will become, if we'll talk about the n is length, length is, and n is the length, right, let's suppose, so it will go to O of n. And if we'll talk about space complexity, right, for this operation, and SC will also become O of n. Why? Because see, where you can say where n is the length of key. Okay, why it is happening? See, because in each operation, the algorithm, we either exchange or create a node in the try till we reach the end of the you can say key. So this takes n operations, actually number of keys, that operation it takes time complexity. And if you'll talk about the space complexity, in the worst case, newly inserted you can say key doesn't share a prefix with the key already inserted in the try, so we have to add new nodes, and which will take us O of n spaces, right. So what we'll do, we'll now implement you can say search for the prefix in try. Okay, so to search in the prefix, let's suppose if we are here. Okay, so if we are going to search, right, let's suppose I'm taking this class. Okay, so let's suppose we are going to search lead, right. So first what we will check, let's suppose we are going to check lead. Okay, so lead you can say lead, right. So we are going to search lead into this into the try. Okay, so we already try contains this data. Okay, so what happened, we will go first, we find L we have, then we will find E we have, then we will find E again we have. So 3 letter we got, now last letter is E, so we got means, and once we come here, so add this node, right, what we will say, our key found, because we have already added this one, right. So this was there. But if we'll talk about any other thing, let's lead funda, suppose lead funda export from lead export funda. Okay, so what will happen, it will say lead key not found, because that is not there, right. So I think you understood. So what we'll do, we'll understand the you can say search operations, right. I'm sorry. So we will now understand the search operation here, and we'll try to implement this one. Okay, so coming to here. Okay, so what we will do, we will implement this one, search one here. Okay, So first of all, we will have our tree node, right? And this is our nothing but our node, right? And it is coming from what? Root. So next what we will do, we'll go to the for loop. Similarly, we'll start with int equal to I equal to, we'll start from 0, and I should be less than word dot length, and we will go to I plus plus. Okay, once this is done, then we will come to what, we will find current letter, or current, you can say text, right? So we have character, this is our current word, we can say our current word, current letter we supposed to say, because we are searching, right? So current letter, and we'll take what, word dot caret. Yeah, so current word will get from here, and this current word will check onto the node. So if node contains what, current letter, then what we will do, we'll continue to check node equal to node dot get the current letter. We'll got our node. If not, if we are not having this node, this current letter onto the node, then we'll return null. And once this is for this loop is done, we will return what, node. Okay, so to find this, we'll do this. Okay, now coming to start. So see, this will return, like we have apple, we're talking about the apple thing, right? So if we are going to find apple into the try, so if apple is there, then it will return, right? Exact, it will return, it will say apple we have already inserted, so it will say true, right? But when we are going to find app, right? So if app is we have already added apple, not app, so it will say not true, it will return what, false, that we have already seen, right? So this is the case we should understand into our mind. Now why I'm talking about, so now we will check the start with, right? So if anyone has already added apple into the trees, right? So either you will find apple, it will say true, either you will find what, app, it will say true. Okay, so to do that, what we have to do, we have to make another function, that is our start with. So start with take what, will take a try node. So this try node will take a node, and it will say will take a search, you can say their name is prefix, search prefix will take, and this will take our this word. So once we find our node, we will return our, you can say, node not equal to null, right? Or we can say and node is and let me write the function. Okay. So if you're talking about the start prefix, right, so we will call like this, right, and we'll implement this one. Okay, okay, so what we'll do, I will rename this one as a this prefix from here, and we'll add here. Okay, so this current letter will find, current letter will check on the, we can say, node, and it will update, right? Similarly, that we have seen the try, right? We are finding that one, right? So this is the thing we have now. Previously, if this is a prefix search we are finding, right? Next time what we will do, let me write here only. Okay, so to find the search, right, what I will do, I can write here, this is our search. Okay, so this search will say if node is not null, means we have some data that is this is not required. Okay, so we have find our what, node, we are passing our word, and from the word we will check this one. You can say, no need to find yeah, this will work. Prefix attachment. Okay, actually I did one wrong, I think. This is this will return what return type we have to check, right? So we will take a boolean, right? And this it should return try node. Actually we're returning node, right? Returning node. Okay, so now what we have, cannot find the symbol word. Where we have word, right? And to find the search, right? Line number 68, this is word prefix. Now run this one. Okay, I'm doing something mistake, I'm doing somewhere. So now first let's understand with the start with, right? So I it is calling the prefix, and this will take our, you can say, whatever the data we have, prefix will use prefix, and will return this one start with. Okay. No, what we'll do, we should use prefix here as the not node, and when we are calling this one search, at that time we should check is null. Is this one, yeah. What I am doing, while we are doing the search, we have to check node should not be null and it should be at the end, right? But when we are calling the start with, we should not we should check only node is not null, right? And it should not be and, right? So that's all for today. Thank you so much, guys. If you like this video, please hit subscribe, so that we will implement more videos like this, and we'll try to come up with more solutions. Okay, so if we'll talk about the search, right, where we have, yeah, so if we'll talk about the search, right, so time complexity will become what, O of n. Okay, time complexity will remain same. And if we'll talk about the space complexity, we are taking only one extra spaces, right? Sorry, constant space, we are not taking any extra spaces, and that's why we are getting like this. Okay, of 1. If we'll talk about search prefix, right, so to we are searching what, we are searching you can say the element search prefix, and that's why we are getting this value, right? And if we'll talk about the space complexity for the start with and the search prefix, will get same. Time complexity will remain same. Okay, so thank you guys. If you like this video, please hit subscribe for more videos.